Hi everyone, I'm Mohammad Saif Ansari. So this is the last video of our Agentic Crack project playlist in which I will set up the agent and the sub agents, and we will see how the main agent will call those sub agents to do some specific task, and we will do this by the line graph in which we will create a graph. So those graph will have the edges and nodes, and the nodes will be the agent, and all the nodes will be agent, and the main agent will call those sub agents through the graph. So let me share my screen and show you. So now I have opened VS Code in our Agentic Rack project file. So let me activate virtual environment. Okay, so now let me add code in this file. Okay, after that I have to code here generate message, and in the pipeline here it is, I have to add whole code now. So where is pipeline? Here it is. So now I have added all the codes, and okay, in get graph generate message and in this pipeline. So why it is still showing this initialize component? So let me import it again. So c dot components dot initialize components import I. Okay, now the warning has gone. So this get graph.py is the most important file of this project. So we are importing these libraries, important libraries, and then we are creating this class which is agent state. So it will work as a state. So there are two most important thing in line graph. The first one is state and the second one is graph. So the state contains some dictionaries that will be passed through each node of this of the graph. So first we are creating this agent state, so that will take as base class of type dict, and we are creating a dictionary that is messages. And okay, after that first we will create this create document function that take this state. So it will take this message and it will return two uh, two binary classes, yes or no. So this generate and this rewrite node. Okay, so this create document function will do determine whether the retrieved document are relevant to the question or not. So it will take as argument of this state message and return a string or a decision whether the document are relevant or not. Okay, so first we are creating this base model of pydantic model uh, that returns binary score or like yes or no. So it will check whether the document that has retrieved from coordinate vector database is actually relevant to the question or not. So we are creating this. Let me do one thing first. So we are creating this generative AI model, which is LLM chat Google generative AI, and the model is Gemini 2.5 Flash. And then after that we are giving this LLM or model this grade class that will check that will give the ability of to this model whether to check the relevance of the document. And after that we are creating this prompt for the model. So the prompt is, you are a grader accessing relevance of the retrieved document via user questions. So first we will give the document that is retrieved from the vector database, and we will also give the question. And then if the document contains keywords or semantic meaning related to the user, the grade it as relevant. Give a binary score, yes or no, to score to indicate whether the document is relevant to the question or not. Then we are uh, giving this input variable like this context and this question. After that we are creating a chain. So first we will give this prompt, and then second we will give this LLM bit tool. And we are from state we are uh, getting the messages. So like here it is, this message from this state, and then we are create and then we are retrieving the docs and the questions from this state, and then we are invoking the chain. uh, so we are giving this input as question and docs at context, so which is here context and question. So this will give ability to this model to check whether there is the retrieved document is relevant or not. So if the uh, answer is yes, then it will call this generate node. If the answer is no, then this uh, agent will call this rewrite node. Okay, then after that we are creating this agent. This is the main node of this graph. So it will invoke the agent model to generate the response based on the current state. Given the question, it will decide to retrieve using the retrieve tool or simply end the process. So it will also take this state as input, and also it will take input this tool. So this tool, I will show you later what is this tool. And then after that it will updated state with the agent response appended to the message. Okay, so first we are giving accessing this message from state, and also we are printing to confirm whether there is a message or not. Then after that we are creating this model, and then we are also binding tools, the tool which we will provide later to the agent. And what tool, after some time I will explain it in the graph. Then we are invoking the model with this message that we have. Okay, then after that we are creating this rewrite node, that here this rewrite node. So let me show you. So it will transform the query to the produced to produce a better question. So first it will check, this great document will check whether there is a need to rewrite. If that is yes, then it will call this rewrite node, and this rewrite node will transform the query of the user to extract better document from the vector database. So first we are accessing this message from state, and we are uh, accessing the question from the content of, so from this message, and we are giving this question to the as human message. So look at the input and try to reason about the underlying semantic meaning. And then here is the initial question, and formulate and improve. So this is the prompt we will give to the uh, rewrite node. So first we are generating this creating this model of this Google Gemini 2.5 Flash, and we are invoking this model by giving this message. Okay, then after that we are creating this generate node. So it will just generate the answer from the retrieved document. So it also take input of the state as message, and it will return a dictionary of updated state with rephrased questions as well. Okay, so first we are retrieving this state message, then question, and then here the docs. That means retrieve document, and we are printing this retrieve document, whether to check that the document has retrieved or not. First we are creating this prompt template, so we are importing this from hub.pull. So it's already predefined a rag prompt, so we will just have to import it, and we are creating this model, and then we are uh, creating an object of this string output parser. So this will do so this will parse the response of this chat model and parse it for to view for better. And after that we are creating this chain. So first we will give this prompt template from here, and then we will give this chat model that will generate the answer, and we will pass it to give better answer. And then we are importing this, invoking this chain by giving the docs and the questions. Okay, so now this is the main class. We will create the graph here. So this is the class in which we will create the graph. So first we will create a function of this get graph, which will take this retrieval tool as an input. So this retrieval tool we will give in the pipeline. So this tool will, let me show you. So the tool which I was talking about in the agent node, this tool, so this tool will be passed, this retriever tool will be passed to the agent node that will retrieve the context from the vector database. So first we will create the state by giving this agent state to the state graph, a state graph. So it will create a state, and then after that we will add node in the workflow. So first we will add this agent node, and we will pass these tools from here. So it will take this partial function will take agent and the tool to this function. Here it is. Okay, after that we create this retriever as a tool node. So tool node is pre-built function that create any function as a tool. So we will add this tool node in a node of this graph. Then also we will do it for rewrite and generate node as well. Okay, so from here we will create the graph. So first we will add this first edge, so that will start, and then agent node will be called. So agent node will get the query from the user from the state, and on this conditional edge, after that on this conditional edge, the use agent will have the ability to choose what to do next. Either it can call this retrieve node or call this generate node. So if on the first run there will be no docs, so it will call this retrieve node. So on this retrieve node, the retrieve it will retrieve the document from vector database, and then on this conditional is the document will be checked whether the document that has retrieved from vector database is relevant or not. So if this generate node give the answer yes, that the document is relevant, then this generate node will be called, and after that the graph will be end. And if the generate node says that the document is not relevant, then call this rewrite agent. Then this rewrite agent will transform the query to extract better document from vector database, and then this agent node will be called. Then again agent node will call this on this conditional edge, check whether to retrieve. So it will retrieve the document, and then again it will check. If the answer is yes, then it will generate and simply in the graph. So now we are compiling this graph from here, and then we will return this graph, compiled graph. So let me go in the pipeline. So in the last video of the pipeline, we did where is pipeline? Okay, so we did till here. So after that we will start from here. So first we are creating an object of this get graph class. Here it is. Then we will call this method of this class this get graph method. Okay, and we will pass this retrieval tool, so that we were talking. So this retrieval tool will go here, and that this retrieval tool as will be saved in this variable, and this variable will be uh, given to this agent node. Here it is, here. Okay, then after that we will get the compiled graph, and after that we will creating a query variable that will store the query from the user that will be given on the extremely tab. Then after that, if uh, uh, user will submit query, click the button of this submit query, then this if condition will check that there is a query or not. So if that is not, so it will just set this warning, please enter the query. If the user has already filled the query, then just it will be saved here like this, human message content, that is query. Okay, so we will after that the process will start, and this generate node will be called. So this generate message, so let me go inside this class. Here it is, generate message. Okay, so first it will get the compiled graph and the input. So these two, uh, this graph and this input. Here we are giving this generate message graph and input. Okay, so first we will set up an empty string here, this generated message, and we will create a loop like output in the graph.stream. So there is two methods to call this compiled graph. There is a invoke method and a stream method. In invoke method, first whole process will be int, then the output will be shown, and in this dot stream method, as soon as the first input token is generated, it will be start showing in the output function. Okay, so that's why we are calling this stream function, and it will take this input, and this input is a query from the user, so it will do all the nodes from here. So here, where it is, here, but first it will from start. Okay, then it will check key and values of the output, and we are printing these two just to confirm. And if the key is generate and the instance is value, so value is actually the this, let me show you, agent state. This message will be the value of this here, and it will check that it is dictionary or not. If that is true, then it will just simply get the message from this message uh, dictionary here, from this mess. Okay, then after that it just simply add this generated message, add this message to the generated message, and it will return it. And also we are printing this just to confirm that it has done, and it will just return it. And after that we will get the message from here, and we will just simply write it here on the streamlit tab, and just simply end the whole pipeline. So that's it. Thank you.